Hey, what's up, guys? So today we're going to be working with solving systems part 2. What we're going to be doing today is we're going to be working with the algebraic version. So again, all that we know about systems so far is that when we're solving systems, basically we're looking for what is the solution that works for both of my equations. Now, when you guys did graphing, again, the good thing about that is it's relatively quick. If you have nice numbers and you're good at graphing, it's a good way to get it visually, but there's a lot of really messy stuff that goes on as well. So when we're doing algebraic, this is the way that you should be solving. There are two major ways to do it, so we're going to jump right on into that. So first off, here's the main thing that you guys need to know as I'm going to talk as I slowly bring up my, where is it? There it is. So again, don't forget graphing is works, but it's sloppy. So today we're going to be doing the algebraic way. There's two ways. First way we have is substitution. Now the main idea is we're using information from one equation to help me solve my other equation. It's kind of like using two different clues to help solve your puzzle. So let me show you a super basic example. Now here's what we know. Almost never will you get systems like this, but this is a system. There's two equations. The first equation we know is that y has to be 2x plus 5. And the second equation we know is that x must equal 3. I don't care what y is, but x is only allowed to be equal to 3. Now, because of this, these are two separate equations, and we have clues from both of them. We know that y has to be 2 times x plus 5, but we also know that x is equal to 3, so what we can do is we can just plug it in. We can say that y equals 2 times by 3, and we can change my x into a 3 because my second equation needs to be true. X is only allowed to be 3. Plus 5. So from here we have y equals 6 plus 5. That means y equals 11. So this is half of my solution. When we're finding a solution though, we need an x and a y. So my full solution is 3 comma 11, because what we know is that x has to be 3 and at the same time y has to be 11. This is true for both of my equations. It's true for the bottom one because x is 3, and it's true for the top one because we know that 3 times 2 is 6 plus 5 is 11, so 11 would equal 11. All right, that's the basic idea. Now I'm going to go very quickly over it because these are the more common examples. This is a little more what it looks like. Very rarely will you be given like x equals 3, y equals 5, and you just plug that in. But this is the exact same concept. We're using both of my equations to piece my clues together. We know that y is equal to 2 of my x's, and at the same time, y is equal to 3x minus 1. Now, if you logically think about it, you might be able to find your solution. But basically, what we know is that y, this y here, is simply 3x minus 1. Because it says so right here. So instead of writing y, what if I wrote 3x minus 1 equals 2x? I just took this y and I replaced it with another way that we can express y, because we know y is equal to 2x, and at the same time it has to be equal to 3x minus 1. We're taking our two clues and we're putting them together. That's the idea behind substitution. The reason it's called substitution is you're saying, well, if I know y is equal to 3x minus 1, I'm going to use a different color just to make it a little easier. If I know that y equals 3x minus 1, then this y has to be true, that 3x minus 1 as well. So instead of writing y, why don't I just write 3x minus 1? That's how systems work, and that's the nice thing about systems. There are multiple clues that we can piece together to solve it. Again, this is called our substitution method. Now, once this is in here, we know that 3x minus 1 equals 2x, and then we can just solve. If I have an x on both sides, we have x minus 1 equals 0, and then we just get x by itself, so that means x has to be equal to 1. Again, is this solving my system? No, it's not. It gave me the x. Now we know what x is, so we can find the y. All we're going to do now is we just plug it back into either one of these. Y equals 2 times 1, so y equals 2. But wait a minute, Mr. Mori, what if we use the other one? Great question! So we have y equals 3 times 1 minus 1. So we have y equals 3 minus 1, which means y equals 2. That means it doesn't matter what equation you're going to use, you're going to get the same y. And again, the reason this works is you put the two equations together to figure out the x. This is the x component of your overlap. Just like how we did graphing, the Venn diagrams, this is the x that's going to tell us where my two lines overlap. So when I'm plugging it in, obviously I'm going to get the same y. That's the whole point of finding this x. So again, let's kind of look at this. Oops, excuse me. Let's go through my solution. My final solution is going to be 1 comma 2, because what we know is x is 1 and y is 2. That's my solution. So moving on. This is the general idea. Whenever you're solving a system using algebra, first thing you do is you isolate or you solve for one variable in one equation. We did that over here. Both of these were already solved for y. That's fine. Secondly, you replace that variable in the second equation. So I have y equals 3x minus 1. I just replaced the y there. Next, we're going to solve for the new equation. Again, my new equation was this part over here. We just solve for the x. And then we repeat using your new variable to find your second value. I'll show you all of this together with these steps listed up here. This would be a good time to pause the video and take notes on it. So again, try this out and make sure that you guys know how to do it. The main thing is we isolate, replace, solve, repeat. I'm going to be saying this over and over just to kind of help give you some mental steps, a little check to make sure you're on the right path. So again, see, I have my rules over here and I'm going to color code it just for you guys. So number one, we're going to isolate or solve for a variable in one equation. Now, this one's already solved for over here, but I'm just going to solve for the second one just to kind of show you what I'm talking about. So first off, what we're going to do is we're going to put 2 here. I'm just going to keep it there so we remember which equation this was. And I just want to isolate y. So in order to get y by itself, I need to get rid of x. The way we get rid of x is we subtract x on both sides. So we have minus x minus x. That means y equals 14 minus x. That's how we isolated y. Step 1 is done. Then after that, we're going to replace the variable in the second equation. So then here, this is number 2. This is what we know, y equals this. That means this y can be replaced with the green y that we found. So we have 14 minus x. I always put parentheses around this, by the way. I'll explain why later. 14 minus x equals 2x plus 4. I just took whatever my y was and then I replaced it. We are substituting it in. So step 2 is done. Now we're going to move on to step 3. I already used green, so we'll use blue. Step 3 says solve for your new equation. Now from here we have 14 minus x equals 2x plus 4. I'm trying to get x all by itself, so we need to get all of my x's to one side. So I'm going to add x to both sides. 14 equals 3x plus 4. And then from here, we're going to just subtract 4 on both sides. So we have 14 minus 4, which is 10, equals 3x, which means x equals 10 over 3. And we just solve it. That's it. Done. Okay, now after we do that, we repeat using your new value to find your second value. Now I'm going to do this in orange because that's a little easier to see than black. So all we're going to do is we're going to take this and put it back into one of these equations. Doesn't really matter which, so I'm going to use the top one. Y equals 2, 10 over 3 plus 4. Again, I just replaced the x with the value that we found at the bottom. Now putting this all together, we have y equals 20 over 3 plus 4. Ugh, we have fractions. Now, it sucks to have fractions, but it's not the end of the world. You guys are at home, you're at computers, plug it into Google, plug it into your calculator, figure out how to do it. But if for you guys who want to remember how to do this manually, you just change this to 12 over 3, lowest common denominator, which means y equals 32 over 3, and that's your answer. Now let me just tell you right now, if you were to solve this 10 over 3 comma 32 over 3, this is your final solution. If you were to solve this, there's no way that you guys would have solved this just purely using the graphing method. You never would have said, oh, that point looks like 32 2/3, which is why we want to use the algebraic method. Does it suck that it has fractions? Yeah, absolutely. It sucks that it has fractions, but at the same time too, it's okay because that's why we practice fractions so much. Use your calculators, use what you need to. All right, now let's move on. That's the first way we solve it. The second way we solve it is using combination. Now combination, basically here are the steps. You match the coefficients of one variable. You subtract the left side from the left side and the right side from the right side. You solve for the remaining variables and you substitute the value found in the original. So again, it's match, subtract, solve, substitute. What the heck does that mean? Let's get into it. So again, let's start off with orange, or I guess on the screen it might look a little yellow. And all it says to do is match the coefficients of one variable. Now, if you remember, this is the coefficients of your variable. If there's nothing, there's always an invisible 1. So, for your x's, your coefficients are 1 and 3. Are they the same? No. So because of that, let's try our next one. 1 and 1. Hey, the coefficients of y are the same. So because they're the same, it's matched. We didn't need to do anything. That's really nice. Second step is green. Subtract the left side from the left side and the right side from the right side. I'm not going to go into why this works because I want to keep this video short. Check out the Khan Academy video if you want to check it out. But all we're going to do is we're going to subtract this left side. So 1 minus 3 is negative 2x. Then we have 1y minus 1y. I'm just going to write my subtraction symbols here to make it nice. 1y minus 1y is equal to 0y, or just 0, and equals to 5 minus 9 is negative 4. All you're doing is you're subtracting the x from the x, the y from the y, and the number from the number. That's basically it. Now, the reason why we wanted to match the coefficients is if you look, now we don't have any y's. We only have our x's, and we can easily solve for the remaining variable, which is step number 3. So we have negative 2x equals negative 4, and which means x equals 2, which is really, really nice. I'm going to move this up so you guys can see it. And again, that's how we solve really, really nicely. And then we're almost done. The last thing that we have to do, whoops, I forgot to check off my green. The last thing we need to do is going to be in red. And then all that is substitute the value you found in one of your original equations. So we know that x is equal to 2, and we put it in either this top one or this bottom one. Again, it doesn't matter. I'm just going to put it into the top one. So we have x plus y equals 5. But we know that x was equal to 2. So we say 2 plus y equals to 5, which means y is equal to 3. So my final answer is going to be 2, 3. Again, we're not looking for x, we're not looking for y, we're looking for the pair of numbers, what works for both of them. All right, that's the main thing with systems. Now, unfortunately, there are some difficult problems here. So let's do one where the coefficients aren't matching. So if you look over here, we'll go back to orange. What we know is we want to match the coefficients. That's not working out because this one's x and this one's 3x. So the way you do it is whatever you do to one side, you're allowed to do to the other. So if I'm looking at this equation, what happens if I times this by 3? Then it's going to be 3x, and that works really, really nicely. The problem is I can't just multiply one thing to 3. I have to multiply everything. So what I'm going to get is 3x plus 9y equals 15. And again, the way I get this is I'm just multiplying everything by 3. I'm multiplying the x and the 3y, and I'm also multiplying the 5. What we're doing is we're trying to match it. And again, the reason why we match is once we subtract, it'll get rid of one of our variables. So from here, we're just going to check this off. We're done. So now we're moving on to step number 2. We're going to subtract. So we're just going to subtract the left side, and we're going to subtract the right side. So from here, we're left with 0, negative 2 minus 9. So if you notice, I'm tapping on my screen to kind of keep track of this. Negative 2 minus 9. Negative 2 minus 9 is negative 11. And then this is equal to negative 3 minus 15, which is, oops, excuse me, forgot my y. Negative 3 minus 15, which, okay. Now, from here, what we're going to do is we just solve for y. So negative 11y equals negative 18. We divide both sides by negative 11, divide by negative 11. So we have y equals negative, or 18 divided by 11. Okay, let me pull that up. And then from here, all you're going to do is you're going to substitute it back in. But I'm just going to kind of leave that for you guys because there's some ugly fractions in it. Like I said, use your calculator, use what you need to. It's not the end of the world. Again, all we're doing here is we're solving systems using our algebraic methods. There are 2 ways: substitution, combination. It doesn't matter which one you use can use whichever one you want. Make sure you know the steps. Again, like I said in the last video, if it would help to see more detailed explanations, let me know. This is just a brief overview kind of showing why things work and how things work. If you want more in-depth, you can always check out the Khan Academy videos, or you can ask me and I can do an example of problems, or just come in and see me. Message me on Remind and see, or like come in and ask for a Zoom or WebEx tutorial, and I'm more than happy to do it. I can even make extra videos going in depth on subjects that you guys have trouble with. Just let me know. All right. If not, good luck, have fun, and let me know if you need any help.